Hi everyone. So here we're going to continue with our statistical and textual analysis of our tweets data, and we're going to go focus on sentiment analysis of the messages. And we're going to import the sentiment analysis intensity analyzer of the NLTK sentiment package. If you notice here, I commented these out, but there are other ones as well. There's a naive Bayes classifier, and I think there are others. But we're just going to use one, and you can explore the other ones if you'd like. And we need to download this lexicon as well, Vader lexicon. And here I'm just kind of doing a reading for the data set that we need. So I'm just pulling up the original data set. Actually, this is the sample data set, but the same format, just kind of half of the posts. You can use the sample or you can use the full data set, and maybe even use both and see if they differ. They should not differ because the sample is, if you do a half of a sample, half of the 60,000 posts, it becomes 30,000. So it's pretty good, and it should be one should be representative of the other, at least the general patterns. So we have our messages here, and we're going to create a sentiment score of the messages by using this predetermined dictionary of the NLTK package. And here we have a function set up to do so. So first here we're importing the sentiment analyzer again, so we don't need to import it twice, just once. But what we have to do is we need to initialize the object, so we call the sentiment intensity analyzer function, and then just put it into an object, which we're naming SIA for short. And then because we're going to need that to edit into to call the functions of the analyzer. Now here we have the main function that analyzes the message, and we may have seen this before, and we're using the lambda and the apply function and the lambda function of Python. And this gets a little bit complicated, and even I am not that good actually on using lambda. You can explore this. It will be very useful if you want to explore this and become a little bit more expert in how to use both the apply and lambda function in Python and pandas. But for our purposes, you may just note that this first statement here is taking the message of it's taking the whole field, and then it's going to apply something to it, and we're going to use lambda. So the main function that we're calling is the polarity score from the NLTK analyzer object, and we're using the compound option. So this compound is something from the analyzer, and what it does is it measures both the positive and the negative of the message and gives it a value based on both the positive and the negative. So it's kind of like a compound score. Now, it's not just plus or minus the positive and the negative, I think. So there's some details here, but actually the documentation is not very good for this. So it's kind of hard to know, but we can use the compound measure, and you can also explore a little bit and see if you can find other measures as well. So what's happening here is that we're just going through the whole data frame, every row of the data frame, and we're applying this polarity score to the x being each row of the data frame, each message, each tweet. And then we're putting all that back into a whole new variable, whole new column, whole new dimension called sentiment score. And just be mindful that we're using the compound score, but it's the score for the whole message. And then on the other one, we actually using the apply and the lambda, essentially we're not calling the sentiment analyzer anymore, but we are using this. We are using our own sentiment score, and we're just categorizing every sentiment score as positive or negative. So actually, the data frame here, I already created it. I already ran this, so I have it in this one here, I think. Oh no, I don't have it on this one here, but I have it on the one. Oh, I have it in the one here. Now we print out. If we print the data frame like this, with only the columns of interest in this way, you can see some of the results. But remember, this is a data frame, and not just a kind of series or list. But what happens is this is going to be a column, and then there's going to be a positive category. So what we're doing is we have a nominal category and we have the actual polarity score. Now, in the following uses, we're just going to use the polarity score or the sentiment score and not really the category, but we may find some interesting uses for the positive and negative category as well. For example, just see how many positive versus negative. But essentially, mainly, these two statements here create a sentiment score and a sentiment category for every tweet. And okay, here it is. So we still have the whole data frame with all the other variables, and also we added these additional dimensions, these additional variables, which is the sentiment score and the sentiment score category. And notice some are 0, some are 0.5, and it goes to 1, and it goes to -1. So -1 to 0 is negative, 0 to 1 is positive. It's kind of like a correlation coefficient, but for sentiment. And we can do a little descriptive analysis here, which is very good to do always to understand what the values are and just make sure it looks valid and just understand everything. So this is a descriptive statistics on the sentiment score that we created. And we see mean, standard deviation, the minimum value. So the minimum value here is -0.968 and the maximum 0.98. So 989. So essentially we have like one that's super negative and one that's almost super positive. So we kind of get the whole gamut. Now, actually, I just noticed something, which is the mean. The mean is 0.2. So it's interesting that maybe, so that means it's 0.2, that means it's slightly positive, right? So if the mean was 0, then it would mean that there's more, well, it's equal, negative and positive. But because the mean is above 0, then it looks like the tendency seems to be positive. And the median here, 50 percentile, is also positive. Remember, the -1 is the lowest possible negative, and the +1 is the lowest possible positive. So if we have 0, it would be neutral, but it's not 0, it's positive. So that means the data is generally trending positive. Standard deviation is pretty large. So that means that most values are within 2 standard deviations, right? Or 1 standard deviation, so it would be what? 0.6. So most values are between 0.6 and -2. I think that's correct. Something like that. Okay, so what are we going to do next? Next, we want to do something like we did before, which is visualize the trend of sentiment over time. So within this 2 years of data, is the sentiment getting more positive in the messages or more negative, right? Does it begin negative? Does it begin positive? And so on. And where does it go from that? So what we need to do is we need to do that aggregation per time. Because remember, we have lots of tweets from lots of different agencies, and there are multiple tweets on the same day, or sometimes maybe no tweets in any day. So we need to aggregate this and kind of get a better understanding of what's happening every month or every day. And I'm suggesting you to do it by day. This GP here, before we had GPM, which means group by month. Now we have GPD, group by day. So we have already went over this code, so you can find it up there, and it's going to be that group by function. We're going to aggregate, and we're going to get a mean sentiment score, not sum. Sum does not make sense. You cannot use sum, but we can use a mean sentiment score, and we're going to aggregate it per day rather than per month. Okay, so we're going to see something like this. Every day we're going to have a mean score of that day. Now, note that this is a little bit kind of, we might lose a lot of information when we do that, because there could be a few posts that are very high positive and a lot of posts that are only slightly negative, and then it kind of, the ultimate score comes out positive. So for example, this one is very slightly positive, 0.02. Now, in this day, January 22, that could have been hundreds of posts that were, or maybe thousands. We're dealing with very big file, so 66,000 posts. So there could have been like 50,000 or 40,000 posts that were negative, and only a few but very positive posts, and it kind of brought this up to a positive. So that's the problem with of course, with any kind of aggregation. But with that in mind, here we have sentiment scores of all the COVID-19 related messages of state public health agencies per day. So it's kind of a little bit weird because we're combining a lot of different agencies all across the country. But anyways, it could be interesting, it could be useful as well. And we can talk about that later. I'm doing something that I did before here where we reset the index. Might not be necessary, maybe not. And then we have the data. The data is here. Essentially, this is it. We got two dimensions, the x-axis on the time and then the y-axis on the sentiment score. That's all we need to create a basic time series graph, and we can just plot it with very few lines of code. And of course, you can add some more, add the legend if necessary, or make some tweaks and some changes. And here we have the evolution of sentiment of the messages. And very interestingly, we see a big kind of volatility on the sentiment in the beginning of the pandemic, which kind of makes sense, right? Because everybody's kind of going crazy trying to figure out what's happening. Generally, the messages have a positive sentiment evaluation. So even though they're all about COVID-19, they have a slightly positive. And over time, over the year, and then certainly beginning even more on the second year in 2021, we see it going up higher. Literally got even more positive, a little bit down, middle of, I don't remember what was happening here, but middle of 2021, and then kind of back up again overall, although of course a lot of ups and downs, but all staying above zero. Now remember, as I was mentioning, this is the average per day of all of the messages of all of the different agencies. So actually what might be interesting to do is kind of separate this a little bit, and I might ask you to do different variations on this calculation to see a little bit how negative were the negatives and how positive were the positives of this data. But I think this can get you going, this can get you started, and I will see you next time.